Hello, everybody, and welcome to another session of Space Expert Talks of our IGLUNA 2020 Virtual Field Campaign. I am Jesus Manuel Muñoz Tejeda. I'm a Space Technology Advisor Systems Engineer for the IGLUNA project, and today I have with me two very special guests. We have Timon, Schild, and Sebastien Lorenz from the European Space Agency. Especially, they are working in the European Astronaut Center in Cologne, Germany, and they have prepared a very nice presentation showing us what is the technology that is currently being developed there and how they came into the European Space Agency and some teams are recommendations for the people that actually wants to join for the next years with them. So Timon, Sebastien, thank you very much for being with us today. And if you are ready with your presentation, you are free to go.
Thank you very much for your introduction, Jesus. I'm just going to share my screen, and there we go. So hello, everybody. Welcome to this presentation. So as mentioned, I'm here today with Sebastien to present to you Spaceship EAC, which is our team at the European Space Agency. So to do so, first of all, I'm going to present you the Spaceship EAC initiative, so the team itself, and give you a quick overview of what we do. And then Sebastien is going to talk a bit more in detail about his personal experience with us as an intern. And I am then going to do the same thing about myself as a trainee. After a short conclusion, we're then going to open the floor to your questions, so please feel free to ask them in the chat. So starting about Spaceship EAC then, perhaps you've never heard of us or heard only a very little. So I'd like to start answering some basic questions about us. So who we are, where we do our activities, why we exist as a team in the first place, and what we do in our day-to-day work. So starting with where, we're based at the European Astronaut Center, so EAC, which is an ESA site located in Cologne, Germany. We are actually on the campus of the DLR, so the German Space Agency. And as far as ESA site goes, we're actually quite a small one. We have around 100 people here. And our main activity is to take care of the European astronauts, as the name may suggest, and we are the home of the European Astronaut Corps. So those activities are divided into three main pillars that you can see here. First of all, training. So we have the responsibility of selecting and training all ESA astronauts. In that case here on this picture, on the left-hand side, you can see Matthias Maurer doing some training in the neutral buoyancy facility, a dedicated facility that we have here at EAC. We also take care of the health of our astronauts. We have a medical team dedicated to monitoring the health of our astronauts before, during, and after each flights. And here to illustrate that, you can see Alexander Gerst doing some medical checkup, actually at DLR, since we collaborate a lot with them on this subject. And finally, we also do the operations, or we take care of a lot of the operations of our astronaut missions, as well as the operation of the hardware, such as the Columbus module on the ISS. To illustrate that, here you can see one of our Eurocoms, which we like to call our voices, or the voice of Europe in space. So all the communications from Europe that go to our astronauts aboard the ISS go through us at EAC through our Eurocoms. So obviously nowadays we're very much focused on the ISS program, but this is to be changed in the near future, since, as you may have understood by now, the next step for human exploration will definitely be the moon, with first of all the lunar orbit with the Gateway program, and then presence on the surface, leading hopefully to a permanent lunar base as envisioned by ESA with its moon village concept. So obviously ESA in general and EAC specifically is preparing for that future already. And to do so, the first activity from EAC is planning and building the Luna facility. This is a new building that will be built right next to the European Astronaut Center, and that will be dedicated to replicate the conditions that you would meet on the lunar surface, both for training our astronauts and also to test our systems and equipment. So this is under progress and should be available in the coming years. And then there is Spaceship EAC, which is also part of this effort of preparation for lunar exploration. We are part of a program called EXPERT, so Exploration, Preparation, Research and Technologies at ESA. And here are our three main missions. First of all, our first mission is to enhance, which means enhance EAC. So use our creativity, our innovation to develop some hardware or software that can actually be used nowadays for today's operation of EAC, since we're very much part of that center. The second one is enable, which is a bit more research focused. So trying to come up with new ideas, new technologies, do some research on them and demonstrate their usability in lunar exploration scenarios. On that aspect, we're actually very close to what the students for IGLUNA have been doing, which is to show new ways to approach human exploration of the moon. So there are a lot of parallels there already between Spaceship and IGLUNA. Our third mission is to inspire, so to bring spaceflight and human spaceflight closer to the general public through things like I am doing right now, so through presentations, but also by publishing our results in scientific papers. And for Spaceship, we also see ourselves as an open door to students and young professionals to get the first experience in the human spaceflight sector. So who are we then? We're a team, as you can see, of young people, as is obvious on the picture on the left. This is a picture from a couple of years back. And we are mostly built around students. So currently we have one ESA astronaut. There's always an ESA astronaut assigned to us. Currently it is Matthias Maurer. One ESA staff member that is the main project, the main team leader, and taking part of the main management processes of Spaceship. Then one research fellow and two national trainees, including myself, also part of the management team of Spaceship on one side, and on the other side doing some technical work as well. And finally, the students, 12 at the moment, who are doing their internships with us for durations between 3 months and an entire year, and working on their side on more technical and research focused projects. You can see that at the moment we're less than 20 people. Usually we're in a bit more. In this picture there are 30. So this means that we will definitely be recruiting new young motivated people in the new future. So if you're interested in joining us, please keep an eye on this space. There will be opportunities that I'm going to address a bit later. Beyond our team, we're also part of a broader network that we can use to our advantage. Obviously, first of all, with other ESA sites. We collaborated a lot with EXAT, ESOC, and ESTEC in the past and present. So ESTEC, for example, have a lot of dedicated facilities for experimental work and testing. So if we need to do some specific analyses, we can usually contact them. We host a lot of students, so we obviously work a lot with academia and other research centers. DLR, of course, since we share their campus, and universities like, for example, EGM, an engineering school in France, that sends us students on a very regular basis. And finally, we also work with companies. That it is also one of ESA's mission is to involve the private sector into space, and this is no different for us. So we collaborate with companies. For instance, we collaborated with Air Liquide on ways of extracting oxygen from lunar materials and purify it. We're also not alone as spaceships. We were the first spaceship created at EAC in 2012, focused on human exploration of the moon. But seeing the success of that, second spaceship has been created in 2018 at EXAT, more oriented toward robotic systems and Mars. And finally, a third one will be created in 2021 in France under the wing of the CNES, so the French Space Agency. So what do we actually do with our time? So our main activities are split into those 4 categories. The main technical work and research work is done in the student projects. Each of our students has one specific project assigned to him that he has to lead, which more often than not is associated to his master's thesis, but it could also be a bachelor thesis or another research work. In addition to that, we also have a lot of, or we also try to do some group projects where we take different students from different backgrounds and put them together into teams that we then can use to our advantage to generate innovative ideas to take part, for instance, in innovation challenges or competitions. EAC activities also is a very important component of our work. Since we are an integral part of EAC, we obviously chip in into projects that go over the entire center. And finally, outreach, as already mentioned, this is what we're doing right now, trying to get ourselves known and get the things that we discover and that we explore out there. Looking at the technical side, our projects are divided into 6 main categories that you can see here. So starting with energy, looking into ways to power infrastructure on the moon. Disruptive technologies, looking at new technologies, not necessarily from the space sector, and apply them to the future of lunar exploration. Space resources, looking at how we could use resources on the moon to enhance our capabilities there further, for instance, by extracting oxygen or other materials. Off-Earth living, very much focused on biology and biochemistry, looking at how we can maintain life on the moon and how we can use life to our advantage with, for instance, plant-based technologies. Robotics is, of course, a very important part of human exploration, and we're looking into aspects such as human and robotic interactions. And finally, advanced manufacturing, where we seek ways to use manufacturing techniques from the present, but also from the future, to build components and structures on the moon, and also to repair what we may already have there. The thing here to notice is that those topical areas are actually very close to the areas from IGLUNA. And I think that most, if not all of the projects presented by the students this week would fit into one or more of those categories. This again shows a strong parallel between Spaceship EAC and the IGLUNA initiative. And we're definitely in the same boat and working towards one objective given by ESA, which is exploration of the moon. What I would now like to do is to go through those topical areas one by one and give you a single example of a project that we did there. I could talk about 20 minutes on each of those projects, but I'll try to keep it a bit short just to give you a flavor and an overview of what we're actually doing. Starting off with energy then, in the past, we've been working quite a lot with fuel cell system, hydrogen fuel cell systems, and had students looking into that in order to gather actual hands-on experience on how those systems work, as well as some more theoretical background and modeling tasks to improve those systems. This is aiming at integrating this technology into what we call the standalone power system, which is a fully integrated power system to be tested and used in Luna. Disruptive technologies, a key aspect of this topic has been augmented and virtual reality and ways of using those. So an example is that we have developed an application, a VR application for astronaut training. You can see here Matthias Maurer doing some pre-familiarization using this technology. And that is a very good example of activities that we do for EAC today and in very close collaboration with some people at EAC to come up with solutions to improve the current projects going on at EAC, such as astronaut training. Going back into much more research-focused territory now with space resources, a very interesting topic we have going on at the moment is using ionic liquids for oxygen extraction. So use a new type of chemicals to extract oxygen from lunar regolith. In that case, we have a chemistry student working on that, and that shows that we have a whole variety of background of people working with us, not only people from aerospace background, but also chemists, and as you have seen previously, also, for instance, computer scientists and a whole lot of different domains. Off-world living, we've been addressing the important challenge of radiation shielding and how we can protect the astronauts on the moon. In that case, by using regolith, and we did a study on investigating the actual effectiveness of regolith in shielding astronauts from radiations. This is again more theoretical work, research work, supported by some simulation work that we did actually publish quite recently in a scientific paper. Robotics, here's an example of a robot that we built called Marvin, which is a system to test both teleoperations and human and robotic interactions that was developed by Spaceship EAC, and in order to first gain hands-on experience with those technologies, build the infrastructure around it, and prepare for further testing at the Luna facility. And then finally, advanced manufacturing. Ongoing topic there is additive manufacturing, also known as 3D printing, where we try to 3D print some complex geometries using lunar material or lunar regolith. In that case, on the right-hand side, you can see a commercial 3D printer that we use with a filament that we built ourselves for that effect, which allows to achieve quite high concentrations, actually, of regolith in the finished component. As a side note, when we're not using those 3D printers for our research, we give access to them to the rest of EAC to manufacture other components, for example, hardware for training. So that's a bit of an overview of what we do at Spaceship. I'm now going to leave the floor to Sebastien, who's going to get a bit more into detail on his own experience here at Spaceship that he gathered during his internship.
Great. Thank you very much, Timon. Also a warm welcome from my side. I'm honored to be here today and to be able to represent all of the interns of the team of Spaceship EAC. It would, of course, be great if we could all be here. But in this case, you get just myself, and I will tell you something about the general life as an intern at Spaceship EAC. So to quickly introduce myself, my name is Sebastien. I am from Austria, which is evident by my accent, but also by the flag right next to where it says nationality. I have been an intern ever since February of this year. I'm in a 6-month internship, which means that I'm actually currently in my last month of the internship. And I've listed some of the projects that I've actually been working on for you right here. You shall be forgiven if you don't know them. They are not as well known as, Project Apollo or the Space Shuttle program, but that's why I will talk about them a little bit later. My background is in computer science mostly, but also a bit of aviation and a bit of astronomy. And because that's very complicated and odd, I thought I might take a bit of a closer look at how exactly I ended up at the European Space Agency. Now, in 2015, I actually graduated from a school, basically an engineering school. I don't think it really exists, the type, anywhere outside of Austria. But it enables you to go to a university. But at the same time, it actually also really focuses on the field that you choose to study. In my case, that was computer science. So afterwards, when I graduated, I already had a pretty good overview and quite good knowledge of computer science. But I thought, you know what, I want to study something different. And I decided to go into astronomy and study that in Vienna for a while, right after my military service, which is mandatory in Austria. And I started studying astronomy. And in parallel, what I did was I started working as a programmer, because it's always good to reincorporate some of the degrees that you have. And I did that combination for quite a while until I actually got the opportunity to move to Switzerland and to start training as an airline pilot for a major Swiss airline, which is called Swiss. Now, even though that mixed up my plans quite a bit, and I had never really planned to do that, to do pilots training, I thought, you know what, let's not pass up on the opportunity, because that's one of those, one in a lifetime chances. And it took me 2 years to do that, but it was really interesting and varied. So we learned a lot about not just flying the airplane, but also learning about how it works, and an introduction to aerodynamics and engineering, which previously I'd never gotten before. And then I was also focusing a lot in the soft skills, for example, managing priorities and teamwork and all that. And after completing pilot school in late 2019, there was supposed to be some sort of waiting period and some time until I could actually start flying the big passenger jets. And I decided I was going to continue studying until then. And that is actually what led me to apply to the European Space Agency and to get the internship at Spaceship. Now, as a quick disclaimer, my CV is very odd. Most of my colleagues don't have it, have a regular looking CV, I guess. They already have their bachelor's degree, and they're now usually in their last years of their master's degree. And most of them are actually writing their thesis here at Spaceship EAC. But for now, enough about myself. Let's look into what does an internship generally look like for everyone, regardless of your background. Well, work is split into basically a couple of different areas. The first one is your main project, which is usually the focus of your work. It has a lot to do with your own area of expertise, and it's actually also your own. You have lots of freedom in where you want to take it and what you want to do with it. But you're still always open to discuss it with the trainees, with ESA staff, with everyone you want to talk to if you're not sure where to take it. And because every intern actually has their own project, and because we have a huge variety of skill sets available, oftentimes you will actually ask other people for help in your project. And others will also ask you for your help every now and then, because you know something that they don't, or the other way around. And that is definitely a huge advantage of Spaceship, is the collaboration between interns. And then additionally, every now and then what you get is are opportunities to work in sort of an additional group project. Those are, of course, by design, very cooperative and collaborative, and they're always a lot of fun. And yeah, those are the general areas. And I will give you a quick or an introduction into what I did during my internship in those three areas. And it will be an example of what, for example, your internship at Spaceship might look like. So first up, my main project. I'm a computer scientist, so I had the opportunity to work on a project in that area. And in this case, it is Internet of Things for lunar exploration. And the entire project is based on a concept that we call sensor confetti, which basically means environmental sensors that are scattered on the lunar surface and that sort of transmit data to a central point where we can then read it and process it. And we are trying to do all of this with commercial off-the-shelf technology, which actually means that the technology that we use, you could buy it off of every website, or not every website, but and we're trying to do that in order to provide a sort of cheap way of doing it. And that is so that these sensors can be, for example, thrown into a deep crater on the moon, or into a permanently shadowed region that humans with bulky spacesuits maybe don't want to go into, or fragile rovers possibly cannot go into. So they would be more or less disposable, but still transmit scientific data all the time while being there. So yeah, the idea is that the sensor data is then sent via LoRa, which is a wireless transmission technology. It's short for long range. And it's a technology just like Wi-Fi or Bluetooth, but it enables you to send data actually over quite a long distance, over 20, 30 kilometers, which is what you need on the moon. And that's why we used it. And it sends the data to all of the other devices, basically, like itself. And then it forms this sort of mesh that you can also see on the screen right now. And the data is sent until it actually reaches a so-called gateway device, which is connected to a computer from which we can then read the data. Now, I'm not the first intern to work on this. The first intern to work on it was actually Jan Zünkler. He's a previous intern. He also worked on it for 6 months. And his implementation of the sensor device can be seen in the left image here. And if you look at that image on the very right of it, you'll see an accelerometer, sort of in blue here. To the left of that, you'll see the antenna, which is professionally mounted, of course, with a rubber band. And then to the left of that, you will you see the Arduino-based CPU, the computing unit, basically. Yeah, and then on the right-hand side, on the right picture, sorry, you'll see the data display in the software where all of the data is collected. And all of those 4 images are different data points over time. So yeah, it's a nice overview. And all of this software actually runs on a Raspberry Pi. And basically at this point in time, Jan left the team and because he came to the end of his stint, and then I took over the project. And yeah, the implementation that Jan had was already very nice. So I focused mainly on simplification and on miniaturization. What I did was I reworked the LoRa network protocol because we had to write that completely ourselves. And I reworked it. And I implemented a different system to store and display all of the data that can be seen in the bottom right here. It now uses an open source mission control software by NASA. It is called OpenMCT. And it's quite nice once you get it to work. Before that, it is not very nice, but afterwards it is. Yeah, I also completely reworked how these sensors are basically implemented and added a lot of new data points. For example, we now support magnetic field vectors and temperature while still using commercial off-the-shelf hardware. So that's very exciting. Then in terms of miniaturization, I removed the large solderless breadboard that you were able to see in the previous frame. And I put all of the electrical elements on a smaller proto board, which you can see in green here. And then for this new setup, I made a case in CAD, which is by now actually 3D printed. And that was especially interesting for me because before that point, I had never worked with 3D printed material or with CAD software even. So yeah, and then that's part of the beauty of Spaceship EAC, is that I could just ask many of my spaceship colleagues if I didn't know how to implement a feature. For example, with this specific, with the case specifically, I worked together with Timon very closely. So yeah, and now it's pretty much the end of my internship. The end result is a product that is already pretty small. The software is already written. And in general, I think the project is ready to be pursued further, either by another intern in the future or maybe by an organization or something. And then maybe one day it will actually find its way to the moon, which would be very exciting. Now, yeah, in terms of contribution to other projects, I was actually able to participate in quite a lot of other interns' projects. If it was, testing specific features or maybe implementing of a specific feature, or every now and then just idea finding. I want to highlight this one specific project by a colleague of mine. She is designing a display for a moon rock that was collected by Apollo 16. And a sketch of the display you can see in the bottom left here. That one will actually be located in the entrance hall of the European Astronaut Center. And yeah, it will feature a sort of interactive display with information about the rock and the mission, and also about the European Astronaut Center. And one of those pages you can see in the bottom right here about the neutral buoyancy facility. And what I did for the project was I worked on the software that basically enables all of the interactivity and also the translations and all of that. Yeah, so it was a very collaborative thing. It was a constant back and forth with her, and very, very exciting to work on it. And then what will be even more exciting will be to see it one day at EAC, standing there in the entrance hall. And if you ever get to visit EAC and you'll find the display, you will, know how part of it was made. Yeah, and then as a last project that I want to show you today, just a couple of weeks ago, one of our colleagues found this public call for ideas on ESA's website, and we decided that we wanted to take part in that. In the beginning, it was supposed to be more or less on our own terms, but then over time, the more we talked to more spaceship people, and when everybody was excited about it, we were actually able to work on it during our regular work time. And it was purely work done by interns. So the idea came from an intern, and the project leader more or less was an intern, and everybody involved was an intern. And it was a uniquely creative process, the entire thing. Yeah, we did everything from brainstorming to find the ideas, to design sprints, to work out the details, and then all the way to actually writing the deliverable. And this call for ideas was about ESA's ER3 lander, which is an unmanned lander that is scheduled to fly to the moon and land on the moon by 2027. And basically the question that they asked was, what sort of payload would you send to the moon if you had the chance? And what we came up with was this idea about a rover that a rover design that can basically carry standardized customer payload, almost like the CubeSat concept, and the rover will provide all of the systems like navigation and communication and so on, and the customers can then simply focus on actually getting their payload onto the rover. And the customer payload is displayed here with the blue cubes. And then the customer, they wouldn't have to focus on engineering a rover from ground up, but they could simply focus on getting their payloads. In general, in a nutshell, I suppose that was 5 or 6 months as an intern at Spaceship EAC. So far, it was a very nice time. I learned a lot, and I'm sure that I will continue to learn a lot for the last 2-3 weeks that I'm here. And for now, I will hand it back to Timon, who will now tell you something about life as a trainee.
Thank you very much, Sebastian. So yeah, I'm now basically going to do the same thing, and you're going to be stuck with me for the rest of this presentation. And I'm going to be talking about my traineeship. So first of all, what is a trainee? So at ESA, trainees are young professionals, so people who just graduated with a master's degree, who are taking a mission of 1 to 2 years at an ESA site within an ESA team and work more or less as an ESA employee would. I, for myself, I'm a Swiss national trainee, which means that I'm actually employed by the Swiss Space Center, which then sends me on this 1 to 2 years mission at ESA. In my case, that was at EAC, working for Spaceship. So here are a few things about myself. So I'm 24 years old. I'm both a Swiss and French national. And as I already said, I'm working as a Swiss national trainee for Spaceship EAC. I actually joined Spaceship on the 1st of December 2019. So I've been here for 8 months now. And I've been working on a variety of different projects, including the ones listed here. So looking on the technical side, looking at how we can use microwaves to process lunar regolith. Then I also took a more coordinating role for the advanced manufacturing team in general. And then I'm also taking care of the 3D printing service that I'm going to talk a bit more about later. And finally, I took part in the Venus Rover Challenge, which is an interesting group project that we had over the last months. But to start with, I'd like to talk a bit about my background. So as you can see here, I'm a mechanical and manufacturing engineer. And this all started in 2013 when I joined the INSA de Lyon, an engineering school in France, where I did my foundation course as well as my mechanical engineering, or my first year of mechanical engineering. In 2016, I got the opportunity to join Trinity College Dublin to continue my studies there in Ireland, where I graduated from with my bachelor's degree in mechanical engineering. And this is also where I wrote my master's thesis on building an attitude controlled test bed for a CubeSat, which is a small kind of satellite. And this is actually only at the master's thesis is when I got involved with space-related activities, especially since I got the opportunity to present my master's work at a conference organized by ESA for students called the Symposium on Space Educational Activities. So this is where I got the first shot at meeting the European space community and working on space-related topics. To finish off my studies, I returned to INSA for 1 year, where I finished my master's degree, and where I also did a 6-month internship, in that case at Volvo, so not in the space sector. And this again shows that at ESA in general and at Spaceship EAC specifically, we're not only looking for people who did aerospace engineering from the get-go, but also for a whole variety of different backgrounds. I mean, as Sebastien showed, we even have a young pilot in our ranks. So a lot of doors, or our door is open to a lot of different people. Then from there, I graduated, I finished my studies at the end of July, and I went to apply to the national trainee program with the Swiss Space Center, and I got my reply there by the end of August from last year, telling me that I will be, in fact, joining the program and start working at Spaceship in December. So in those last 8 months now, I've been working in the following areas. So on the top and left-hand side, you can see obviously technical research work, Spaceship group project and EAC activities, which are, I would say, the more R&D parts of our work, and also the parts that are similar to what an intern would actually do at Spaceship, as Sebastien already explained. And then on the right-hand side, you can see team coordination and Spaceship administration. As a trainee, you are part of the management team of Spaceship, and you get to lead a team of students, and you also are part of the administrative processes, such as the procurements for the team, or also the recruitment of new people. So I'm now going to give you a bit of an overview of what I did in those different fields during my time here, to give you an idea of what you might be doing if you decide to join us as a trainee. So first and foremost, there's still, of course, the technical work, which is at the heart of the traineeship. And I have 2 examples here, although I'm working on a few projects in parallels. Those are perhaps the 2 standout examples and the most easy, I would say, to encompass in that presentation. The first one being the refurbishment of an experimental 3D printing setup that we had in our lab. So this was some work done previously by another member of Spaceship, and that I basically came into and had to complete. Starting with an already quite advanced design and then finalizing it to now have a functioning experimental setup. This is the structure you can see on the left there. And on that side, it was a very good way for me to enter Spaceship, since it allowed me to work in my field of expertise, which is mechanical engineering, and to find my footing there. So it's always very nice and reassuring in a bit to be working on stuff you already know. On the other hand, I've also been working on microwaves, which is a field I didn't know much about. So we are currently investigating microwaves as a way of processing regolith, so to heat it up, either in order to sinter it and to make structures out of it, or just to extract some volatiles out of it, such as oxygen. So I did some, obviously, a lot of reading on that topic to familiarize myself with it, and then some experimental work, and finally, during lockdown, also some more theoretical simulation work. And that shows so Spaceship gave me a great opportunity in a way to address a completely new technical area that I had only very little experience with, and I got the chance to get fully involved in that and to dive deep into a new technical subject, which is always, of course, very interesting. Moving on now to the less technical stuff. A major part of my work as well as Spaceship is the team coordination aspect. So I am part of the advanced manufacturing team together with 2 students, Benoit and Billy. And I am actually coordinating this team. So I'm the person of contact for those students, and I have the role of supervising their projects and supporting them if needed. Since as a trainee, I'm present longer than most of our students. I'm also in charge of the on and offboarding of the students to allow some continuity in our different projects. So obviously, the students that we have at Spaceship EAC are mostly brilliant and very autonomous. So there isn't much work to do in terms of managing and coordinating them, but it's still a very good experience for myself to discover the world of team management and project planning, which I didn't have a lot of experience of before. So a great opportunity for me on that side. Similarly, I've also taken part in group projects, the main one being the Venus Rover Challenge. So the story behind that is that was, again, an open call for proposals, in this case from NASA, who opened this call since they wanted the general public to think about and to design an obstacle avoidance system for a rover they want to send on Venus. The tricky part being that this system had to be fully mechanical. So obviously, as a mechanical engineer, I had to jump on this opportunity, and together with other people from Spaceship, we founded a team of around 10 people and started brainstorming our way at this challenge, ending up with the proposals that you can see here. We actually did get the results last week, and we got the honorable mentions on that. So it's always very nice to get some feedback, some recognition of your work, and also to contribute to the to making Spaceship more visible to the outside. On that specific project, I've taken on obviously some of the technical work, but I've also been the main project coordinator and project manager, which means that I again could learn a lot on team management and project planning. So here again, very very interesting way to learn new skills, and not only in the technical domain. The last point I wanted to address would be EAC activities. So as we already mentioned a couple of times, Spaceship EAC is definitely part of EAC. It is in the name. And one of the things I do in contact with EAC is managing the 3D printing service that we have there. So we have our 3D printers that we use for our research on additive manufacturing. And when they're not used for that purpose, we actually are in contact with the rest of the EAC employees who can access them through us if they wish to produce some component. For instance, if someone needs a purpose-built hardware or a small replacement part for training activities, they can reach out to us and we can find a way to manufacture it. On the image you can see here was one of the very good applications that we had for that service was actually to print face shields during lockdown. So that were then delivered to hospitals and other medical institutions. And that was obviously a very rewarding task to do. And also I'm also very grateful for, first of all, Spaceship, but also EAC in general for letting us use those resources in that way to contribute to pandemic mitigation. And when you're not in the scenario of a global pandemic, those EAC activities are obviously a very good way to get to know people from outside Spaceship who have all a lot of experience to share, and you can definitely learn a lot from them. So this is more or less it for the overview of my traineeship and what you can expect. You could expect as a trainee when joining Spaceship. So I'm now going to start concluding this presentation by summarizing why you should join Spaceship EAC from the different points raised by Sebastien and myself. So first point here, I think we both agree with Sebastien, is that Spaceship EAC is a very positive environment to work in and very open to everyone and dynamic. And since we have a lot of young members, there's always something interesting going on either at work or outside of work. there is a great diversity in people. A lot of different backgrounds are represented, and also the technical projects, as we have already seen, are very varied. And you will get the opportunity to learn new skills, be it technical or non-technical. In my case, on the technical side, that would have been microwave engineering, which I'm still in the process of diving into and understanding. And Sebastien, for instance, also gave the example of CAD design, which you get involved with for the first time and learned how to do. You also get a lot of freedom and responsibilities in organizing your project work. Obviously, for trainees, since we're part of the management team of Spaceship, but also for interns. I mean, the perfect example of that is the Cream Rover project that Sebastien mentioned, which was entirely led by students. They came up with the idea, they implemented it, they submitted it, and they did a very good job with it. And we at Spaceship are, of course, very happy to welcome and encourage those initiatives. Then you're not just working at Spaceship EAC, you're also working at EAC in general. So you will get the opportunity to meet and work with a whole lot of interested and much more experienced people there. So compared to us as students and young professionals, those are veterans of human spaceflight and space and the space domain in general. And there's always a lot to learn. And they're all very, very open in sharing their experience, either during common projects or be it over a coffee or during lunch. A bit more specific to the trainee role, I actually get access to an individualized mentorship programs through Spaceship EAC. So I have an ESA staff that is my mentor from outside of Spaceship, and that I can be that I have a privileged contact with, and that gives me some feedback, some advice on how to best do my work, and also provides me with an outside perspective, a perspective from outside of Spaceship EAC. And finally, we're all part of ESA, so we get access to some of the resources there. Interns and trainees both can attend public talks or lectures that are given on site or currently through video conferencing. For trainees, we can actually access some more resources, such as online courses and training courses aimed at ESA staff, which is obviously very interesting and can help develop your profile even further. So now that I've convinced all of you that you should try to join Spaceship EAC, I'm going to conclude the presentation by telling you how you can join, how you could have the opportunity to join us. So there are a few different options. The first would be the Young Graduate Program, open to to everyone from an ESA member state with a master's degree. And we publish those opportunities every year on November. So definitely keep an eye open for that. Those positions are all across ESA. And at Spaceship, we're always looking at getting at least one young graduate trainee on board. Then we have student internships. We at Spaceship obviously rely a lot on that, and we will publish some new offers at the end of the year, probably as soon as September. So definitely keep an eye open. Those will all be on the ESA career portal and open to students from all kinds of backgrounds. There are also, of course, other internships elsewhere at ESA, so definitely go have a browse there. And then the final way of entering, which is the way I choose, is National Trainee Program. So through the different national agencies, which you have to contact directly. In my case, it was through the Swiss Space Center and through their website, where those call for applications were posted. But there are also other agencies doing similar programs in Belgium, Germany, Portugal, Ireland, Luxembourg, and Estonia. So I definitely hope that you will, if you have the opportunity, give this a try and I'm definitely looking forward to perhaps meeting some of you in the very near future. That concludes this presentation. Thank you very much for attending. I hope you found it somewhat interesting, and I'm now going to take a few questions from Jesus.
Thank you very much, Timon. Thank you very much, Sebastien, for this really nice presentation. It's been really nice to know more about your background with your experience in the European Space Agency. And as Timon said, although the European Astronaut Center might be not as known as other places of the European Space Agency, you really have very impressive programs over there. So it's been really nice to know more about them. We don't have too much time for questions. We just have 10 minutes. So I will ask you, Timon and Sebastien, to just give a short overview of the answer so we can address as much questions as possible from the public. I have divided the questions into two domains. We have some more technical ones and another ones related to the career at ESA. So I will start with the more technical ones. And the first one that came from the public is related to the astronaut training, because we saw at the very beginning that you have the astronauts and this kind of space talks underwater. But the public is interested in knowing how realistic these underwater walks are related to what exactly they do in space. Do you think it's a realistic approach? And moreover, if there are more characteristics that you actually replicate when the astronauts are going underwater. For example, if they test radiation, temperature difference, how is the actual training of the astronauts?
Yeah, very interesting question there. So that's not completely my field of expertise, but I'm going to try to do the best at answering those. So yeah, definitely training in the water is the easiest and the best we can do, I think, to replicate zero-G conditions. There are other alternatives. Our astronauts also do parabolic flights, which are closer to what they would experience in actual weightlessness, but also on the downside, you can spend less time there. The main advantage of neutral buoyancy training is that you can have fully emerged replicas of as you saw at the beginning of this presentation, for instance, the Columbus module. So it's still used a lot, especially for training for EVAs, so extravehicular activities.
Mm-hmm. Absolutely. And now that you mentioned the technology that you are over there, is there any of the devices that you've been doing at the European Astronaut Center actually in space? Are they for example, in the International Space Station, or are they still in the TRL on the Earth level?
That's an interesting question. We're actually currently, so over the last weeks, we've been looking into getting some of our proposals into the ISS, so trying to propose some experiments, not fully developed systems, but some experiments that we did on the ground and that we think would be very interesting to do in space. An example I can give there is on radiation shielding. We have that regolith simulant that we use for our experiments on the ground, and we would like to take some of that on the ISS to verify their properties up there. Yeah.
Mm-hmm, absolutely. And now you talk about all these experiments. I think it's really encouraging for the people to develop these ideas on the Earth level and then increase the technology level by performing, for example, a parabolic flight in order to simulate or directly into the space. For example, Sebastien, you were developing the Cream rover. And I would like to know about the specifications about your idea, because you said it was flexible, that people can put their payloads inside. What kind of space will be available in the rover? Which kind of payloads are you targeting with? Because the payloads, of course, depends on the customer, and the customer has different shapes and different technologies inside. What kind of payloads can you put inside the rover, actually?
Yeah, that is a very good question. So we tried to be as open as possible with what sort of payloads you would be able to put on the rover. So on one hand, you would have the sort of smaller CubeSat type standardized systems, but we also have a standardized space that people can put their robotic payloads on. You know, when it comes to, for example, sample return. missions or maybe a robotic arm, we also have a place on the rover where we could interface that onto. So yeah, it is a very varied rover, and we always try to be as open as possible with our with our design.
Absolutely. Was the idea finally selected, or in which kind of process are you right now?
We don't know yet. We only submitted it, I think, about 2 weeks ago or 3 weeks ago, something like that. So it's in the process of being judged and everything. So we will know in a couple of weeks or months.
Thank you very much, Sebastian. Good luck with your idea. Now, I would like to focus a little bit more on your careers. We saw that you both have different backgrounds. Sebastian, for example, was studying astrophysics, then he was training as a pilot. So in this area over here, I would like to know what are your next steps in your professional development. First, Timon, you could ask, and then Sebastian might take the lead of it afterwards.
Okay, well, that is a very interesting question. I'd be interested in the answer to that as well. So on my side, in the near future, of course, it would be the renewal of the 1-year traineeship contract, which I hope will succeed. So I should be here for at least 1 more year. And then one path I would consider for myself maybe would be going into staying into the technical R&D part, either in the industry or perhaps even going down the road of a PhD thesis, if I find, of course, an interesting topic somewhere.
That is very interesting, and from my side, I think it's the $1 million question, right? What's going to happen in the future, especially now with the uncertain times that we currently have. You mentioned it earlier, Jesus. I did the pilot's training. It's sort of on ice, everything when it comes to aviation. So I'm actually very glad that I ended up more or less by accident in space exploration. And I'm for now going to finish up my internship, and I already have another job in space exploration lined up more or less, which is very exciting. And I will definitely, I definitely want to learn more about the field, about space, and about everything. So it's definitely interesting times ahead, but also uncertain times. But it's the same for all of us.
Yes, absolutely. This is something everybody is facing. And I would like to know more, because right now you are working for the European Space Agency, but is it possible to continue in this experience, or the people that are joining are in a fixed term and that they will have to find something else, where, for example, in another company, or you can actually be in the European Space Agency for 2-3 years more if you want?
Yeah, go ahead, Timon.
I'm going to take that one, perhaps. So on the ESA side, so the trainee program is definitely limited in time, so it's 2-year maximum. And after that, well, you can apply directly to an ESA staff position, although traditionally those are mostly open to more experienced people. But there are still ways to stay involved. PhD is actually a good one. There are some funds or some funded PhD programs from ESA. And also there are a lot of people who are working for contractors as a way of getting into ESA and then evolving into a ESA employee and ESA staff positions. In any case, something that's often brought up is that in the coming 10 years, ESA will face a huge wave of retirements. So there will definitely be a lot of renewal of people, and there will be a lot of new opportunities, I guess, to join the European Space Agency.
Absolutely. Thank you very much, Timon. And we really share your passion for space, and also with you, Sebastian, because it's been really nice to know more about what you've been doing. And I had a lot of people in the comments actually really inspiring and willing to join you in your adventure at the European Astronaut Center. We don't have too much time now. I know we have more questions from the audience, including if you guys are single or not, but I guess we can leave your email in the description for this kind of professional and not professional questions for the rest. I would like to thank you very much, all the audience, for watching, and I will see you tomorrow with another project show. Bye-bye.